Welcome, game developer hobbyists! This is the final episode of a game development series for our classic game of Pong. As you can see here, I've added game options for paddle size and ball speed, as well as some simple AI options. I kept track of each improvement as an issue over on my Github account. In order to add game states, I first went through a bit of refactoring on the Match Renderer class. Splitting up the rendering into separate methods for drawing the court, score, and game elements allowed me to piece together the scene for each game mode however I liked. When it came time to add the ability to pause the game, I realized this getAsync keystate function wasn't going to cut it. It's only really useful to tell if a particular key is currently being held down. Fortunately, FreeGlut comes equipped with its own keyboard handler that can process keystrokes. In order to handle the transitions between game modes, I refactored the keyboard checks into individual methods for each mode. I then added a match 1 scene when a player reaches 10 points. Rather than add some kind of reset method on the match class, I decided to go with the approach of deleting and recreating the match instance. This did involve changing the game client class to maintain the match definition as part of its state. With the game states in place, I tagged the Git repository as Pong130. In order to start adding game options as a feature, I was going to need some sort of logic to allow the user to navigate between options and choose option values. The Match Options controller class achieves this. I arranged its state into a simple array indicating the current value of each option, and another array indicating the maximum option value. This lets the update method cycle through option values with the left and right arrow. Each game option will have its own pair of methods. The getPaddleSize method is called when the user closes the option menu in order to update the match definition, and the getUpdateOptionValue method is called by the Match Renderer class to provide user feedback on their current options. Adding ball speed as a game option was now trivial, as we just hooked the new option into the Match Options controller and Match Renderer classes. And of course, our Pong game would not have been complete without
ludicrous speed! They've gone to plaid!
The option to play against a computer was what I considered to be the most important option. Here I introduced a new paddle control source enum, and made it part of the paddle definition. At this stage, I placed the AI behavior directly in the game client class. It simply checked where the ball was vertically and requested that its paddle move to intercept it. After a little experimentation, I was intrigued by the notion of having several versions of this follower AI behavior. I first refactored the AI behavior to become part of the paddle state. This paddle AI virtual base class provides a common interface that the paddle can call to execute any AI behavior. The follower paddle AI class is our first implementation. I provided 2 parameters for it. The paddle height multiplier tells the AI how closely it should follow the ball, compared to the center position of the paddle. And if the only follow if ball is approaching flag is switched off, the AI will stop moving whenever the ball is moving away from the paddle. So I provided 3 variations of the follower AI. The late follower tracks the ball near its edges, and only when the ball is approaching. The regular follower always tracks the ball near its edges. And the close follower tracks the ball near its center position. To help get things going when pitting AI against AI, I also added this little snippet that tells it to move the paddle down if the ball is in line with its exact center position. I also added a guesser paddle AI. This simply uses a random number generator to occasionally change which direction to move. It has a 5% chance of changing direction when the paddle is fairly central in the court, or a 50% chance if it's closer to the edges of the court. I called the final AI behavior the Snooker Pro. The idea here is to predict where the ball will cross the plane of the paddle. This makes use of the court collision checkutil class that I discussed in the previous video. It treats the court as if it's completely closed off by the paddles, and it extends the ball's path to twice the width of the court, guaranteeing that the check will hit our paddle. When it does hit the paddle, we simply use the Y position of the collision to tell the paddle where it needs to be. To make it more interesting, I also added some logic that tells it to move the paddle just before the ball hits it. Its choice is randomized and provides a little realism as it appears to be trying to fake out the opponent. And with all these improvements in place, I was ready to release Riley Entertainment Pong to the public. I tagged this as Pong150 in my Github repository. You can grab the source code there, or download the zip file of the game itself. There are a few little things that do still annoy me. The text doesn't center properly when you expand the window, and it opens as a console window, which I admit I did occasionally use to output AI decision information during development. There's also no sound effects or music. But it's a functioning game of Pong, with some decent game options and AI behaviors that I'm quite happy with. Onwards and upwards for me from here. Next, I'm going to explore a library called SFML, short for Simple and Fast Multimedia Library. Stay tuned to this channel for future game development, and check out my GameDev.net profile for more details. Thanks for watching.